try to solve some problems on single random variable in this video. And let us try to solve some problems. Before that, let us recall whatever we have studied earlier. Differentiation of characteristic equation, characteristic function with respect to j omega. This n times will give us the integral of x to the power n fx of x e to the power j omega x dx. From this equation, you can obtain the expectation by making this omega value equal to 0. Then we can find out E of x or E of x squared or E of x cubed, so on. Let us try to solve some problem. First problem is we need to find E of x and E of x squared from the characteristic equation for the uniform random variable. For a uniform random variable, characteristic function is given by here phi x of j omega is equal to e to the power j omega b minus e to the power j omega a divided by j omega b minus a. Let us consider a random variable x which is uniformly distributed between 0 and 1. So we are considering the period fx of x which is uniformly distributed between 0 and 1 and which is 1. And we can find out the characteristic function by integrating. We know that the characteristic equation is given by integral of b to a fx of x e to the power j omega x dx. Here fx of x is defined as, here you can observe, for this I can define fx of x is the 1 divided by, b value is 1, a value is 0. So 1 divided by 1 minus 0. That is substituted here and it is integrated from 0 to 1 e to the power j omega x dx. So when you integrate this, you get this as e to the power j omega minus 1 divided by j omega. You can expand this e to the power j omega as 1 plus j omega by factorial 1 plus j omega squared by factorial 2 plus j omega cube divided by factorial 3 and so on, and minus 1. Minus 1 we can add it. In the denominator we have j omega. This 1 and this 1 will get cancelled out and we have j omega divided by j omega, that gives us 1. Then j omega whole square divided by j omega will give us j omega divided by factorial 2 and so on. You get plus j omega square by 3 factorial plus j omega cube by 4 factorial, so on. We make use of this equation in order to find the expectations E of x and E of x square. So E of x means here n value is equal to 1. So I need to differentiate this characteristic function only 1 and then I have to substitute omega is equal to 0. So let me differentiate the characteristic function, that is 1 plus j omega by 2 factorial plus j omega square by 3 factorial, so on, with respect to j omega, and let me substitute omega value is equal to 0. So when I differentiate this, I get this with respect to j omega will give me 1 divided by 2 factorial. This will give me 2j omega by 3 factorial plus 3j omega whole square divided by 4 factorial, so on. And I need to substitute the value of omega equal to 0. So all these terms will get cancelled out and I am left with only 1 by 2 factorial, that is equal to 1 divided by 2, that is half. So when I want to find out the expectation x square, I have to have n value is equal to 2. That means I have to differentiate the characteristic function twice. I have already differentiated this and I have 1 and I have got this. Now I need to differentiate this once again. When I differentiate this once again, this term will vanish. Next term will be 2 divided by 3 factorial. This will be 6 divided 6j omega by 4 factorial, so on. Then I need to substitute the omega value is equal to 0. All these terms will get cancelled out. I am left with only 2 divided by 3 factorial. That gives you, this is equal to, it is 1 divided by 2 into 3, and in the numerator I have 2. So therefore I get this value as 1 by 3. So knowing the expectation of x and expectation of x square, I can always find out the variance of x. And variance of x is given by ex square minus ex the whole square. So ex square, I have got it as 1 by 3 and e of x is 1 by 2. So 1 by 3 minus 1 by 2 whole square, that gives you, here it is 1 by 3 minus 1 by 4. So you get this as 12, 4 minus 3, that gives you 1 by 12. This is equal to standard deviation whole square. So therefore, standard deviation is equal to root of 1 by 12. Let us try to solve the second problem. We are expected to find the expectation of x and expectation of x square from the characteristic function or Laplace random variable. For the Laplace random variable, fx of j omega is given by b square omega square plus b square in the denominator. Let us take a small modification here. J omega whole square is equal to j square omega square, that gives you minus omega square. Therefore, you have to substitute, if you want plus omega square, then it has to be substituted as minus j omega whole square. That substitution is done here, and we have written the equation b square divided by, in the denominator, minus j omega whole square plus b square. Now we need to find the expectation of x. That means I need to differentiate this characteristic function only once, and I need to put the value of omega equal to 0. So when we do this, you get this answer as, when I differentiate this, I get this as 1 divided by b square minus j omega whole square, the square, minus 1 in the numerator. You get this as minus 1 into differentiation of in the denominator term, that is minus 2j omega, and constant term is b square. So here you are putting omega equal to 0. When you put this omega is equal to 0 in this equation, you get this as 0 divided by b to the power 4, that is equal to 0. So therefore, you can write that expectation of x equal to 0. Now we need to find expectation of x square. That means I need to differentiate the characteristic function twice. Already I have differentiated once and I have got this expression. I need to differentiate this once again, and whatever answer I get, I need to put the omega value is equal to 0. So let me differentiate this. When I differentiate this, I get this as b square minus j omega whole square, the square, and it is 2b square minus 2b square j omega. It is 2 times 2 times b square minus j omega square, the square, and differentiate minus 2j omega divided by denominator term, that is minus j omega whole square b square, the square. So it is 4. So when I substitute omega is equal to 0, so this term is 0. All these terms are 0. So I am left with in the numerator 2b to the power 4 divided by this term is 0. So b to the power 8. So that gives me 2b to the power 4 into b4 into b. It is b to the power 4 into b square in the numerator, b4. So 1 b4 will get cancelled out. So I am left with 2 divided by b square. So once I know the expectation of x square, I can find the variance of x. It is the expectation of x square minus e of x whole square. Expectation of x square is 2 divided by b square. Expectation of x is 0. So therefore, I get the variance of x is equal to 2 divided by b square, that is equal to standard deviation whole square. So from this I can find the standard deviation, that is root of 2 divided by b square. Let us try to solve the third problem. Third problem is we need to find the expectation of x and expectation of x square from the characteristic function for exponential random variable. For exponential random variable, the characteristic function is given by phi x of j omega is equal to lambda divided by lambda minus j omega, where lambda value is greater than 0. Expectation of x is we can get by differentiating the characteristic function only once and putting the value of omega is equal to 0. And when we differentiate this expectation of the characteristic function, we get the answer as it is lambda divided by lambda minus j omega whole square minus 1. That gives you lambda divided by lambda minus j omega whole square. Substituting the omega value is equal to 0, we get this as 1 divided by lambda. Now we can get the expectation of x square. That means I need to differentiate the characteristic function twice. Already I have differentiated once and I have got this answer. And when I differentiate this once again, I get expectation of x square is equal to, here the lambda is a constant term, minus of 2 times lambda minus j omega to the power 3 minus 1. So here if I put the value so this can be further written as 2 lambda minus it is 2 divided by it is 2 into lambda divided by lambda minus j cube the whole cube. So when I put the value of omega equal to 0, I get this as 2 divided by lambda square. So expectation of x square is given by 2 divided by lambda square. By knowing expectation of x and expectation of x square, we can find the variance of x, that is given by the expectation of x square minus the expectation of x the whole square. That gives you 1 divided by lambda square, and this is equal to sigma x standard deviation whole square. So standard deviation sigma x is root of 1 divided by lambda square. Let us solve the fourth problem. The random variable x is uniformly distributed between 0 and 4. The random variable y is obtained from x using y equal to x minus 2 whole square. What are the CDF and PDF for y? Here we know that x is uniformly distributed and the distribution is shown here. It varies from 0 to 4. Its value is 1. This is the PDF for x. Now y and x are related by the equation y is equal to x minus 2 whole square. So therefore it is root y plus or minus root y is equal to x minus 2. Therefore we can say that there are two values of y. Y is between the first value is root y plus 2 is equal to x. Another value is minus root y plus 2 is equal to x. Now we have to find the CDF. CDF is given by the probability of y less than or equal to y, and probability of x less than or equal to x is given by probability of y less than or equal to root of plus or minus y plus 2. That gives you the probability of fx of root y plus 2 minus the probability of x probability of minus root y plus 2. We can obtain the CDF by differentiating the CDF function. When I differentiate this with respect to y, I get the answer as 1 divided by 2 root y fx of x plus 1 divided by 2 root y fx of x. Now this is equal to, you can write this as 2 times 2 root y fx of x. This gives you 1 divided by root y fx of x. And here from the figure you can observe that fx of x is given by 1 divided by 4 minus 0. So I can write this as 1 divided by root y 4 minus 0. That gives you 1 divided by 4 root y, and that is defined for all values of y varying between 0 to 4 minus 2 whole square, because it is given as x minus 2. X can take maximum value is 4. So 4 minus 2 whole square. Let us solve the fifth problem. Resistors R are uniformly distributed in the interval 50 plus or minus 5 ohm. That gives you here plus 55 to 45. From the circuit theory, we know that conductance G is equal to 1 over R. We need to find the CDF and CDF. Now, this is given, R is uniformly distributed. So, we can write the CDF. The CDF varies from 45 to 65. And value is 1, which is FR of R. So FR of R for a resistor is given by 1 divided by 55 minus 45, that is equal to 1 divided by 10. Now Fg of G, that is the CDF, is given by probability of G less than or equal to G. That is equal to probability of R less than or equal to R. That is R less than or equal to 1 over G is equal to FR of 1 over G. So by differentiating this with respect to G, I get Fg of G, and that is given by the 1 minus 1 divided by G square FR of R. That is equal to minus 1 divided by 10G square. And the G value varies between 1 over 55 to 1 over 45. Thank you. In the next video, we will solve some more problems on single random variables.